A good approach to be able to change things is to have code that is as little dependent of one another. If a piece of code is dependent on another one, any change in the latter will imply a change in the former. And this is not good. You will need to live with changes, so you would profit if these changes don't imply changes elsewhere. Let's model geometric objects on a plane. First, we need to model points on a plane. A point is characterized by its two coordinates x and y. And once we have defined a class for points, we can define a class for line segments. A segment is defined by 2 points, so an object of class segment has 2 objects of class point. Here we see the class point. Very simple. We have 2 attributes or instance variables x and y. We define them of type double. The constructor point takes the 2 arguments and stores them in the corresponding attributes. Once we have defined class point, we can define class segment. A line segment is defined on a plane by giving 2 points. Therefore, we define 2 instance variables or 2 attributes for 2 points, a and b. Then we define a constructor segment in a straightforward way. And we also define method length to compute the length of the segment as the square root of the difference of the x values of the point squared plus the difference of the y values squared as well. Easy. For computing the segment length, we use the x and y values of the 2 points a and b. But there's a problem with this approach. If we decide to represent the points in a different way, we need also to change the class segment. For instance, if class point does not use the Cartesian representation with coordinates x and y, but the polar form with an angle and a modulus, we need to change class segment. We need to make the definition of class segment as much as possible independent from the internal presentation used to define points. Here we have a better code. This time we make both attributes x and y private. Maybe you already wondered why we have not done this from the very beginning. Well, it was to illustrate the point. Well, they can only be used inside class point. But segment needs this information. Therefore, we define 2 methods, getX and getY. And these are used inside class segment. At first sight, it seems that we have not done much. But if we decide to keep the point representation in polar form with a modulus and an angle, there's no problem in doing that. We use attribute r for the modulus and attribute a for the angle. And how about getX and getY? They are needed in class segment. No problem, we redefine their bodies in class point. GetX just computes r times cosine of a, and getY r times sine of a. Notice that the change stays local to class point. There is no change at all in class segment. So every class manages their own data and exposes to the outside whatever is needed. This allows us to control the internal representation independently of the use we make of it. So the first thing to notice is that encapsulation, if well done, helps us to reduce the coupling between pieces of code. So we look for loose coupling because this allows us to manage our program better. Loose or low coupling implies less coordination among program parts and less propagation of changes. So the first tool to help us achieve this is the encapsulation mechanism of classes.